Happy Monday, everyone. My name is Patrick Hess. I'm the Planetarium Specialist at Union Station. Thanks for joining us for another Planetarium live stream. And if you're joining us for the first time, welcome. We're so glad that you're tuning in. And if you've been tuning in for the past bunch of weeks to our streams, then welcome back. Thank you so much for supporting us through all of our streams and through all the changes that we've been doing during the streams. And as we've been talking about over the past few weeks, Union Station is preparing to reopen to the public. And we will be reopening to Union Station members only this Wednesday. And then next Wednesday, we will be open to all public. So I'd encourage you to go to unionstation.org and find out more information about how we're opening and what safety measures we're taking with the ongoing pandemic, of course. And you can purchase tickets there as well. And as we reopen, our streaming schedule is going to shift a bit, but don't worry, we are going to continue our live streams, which I'm very excited about. These have been a huge hit and a lot of fun for me, for sure. And it seems like you guys are enjoying them too, so we're going to keep doing them for the time being. And we're just going to adjust things a little bit because we are opening back up. I will be seeing you guys at the Planetarium Wednesday through Sunday, and we will be closed to the public on Monday and Tuesday, but on Monday nights at 6 p.m. I'll be seeing you right here in outer space where we've been streaming for the past couple months. So Monday nights, again, is the new streaming schedule at 6 p.m., keeping it at the same time. And we're going to do a mix of content. Today's stream will be a bit short. I'm going to just give you a little preview about our night sky and specifically the star tour that we will be spending our time under at the Planetarium, hopefully encouraging you all to think about coming and supporting us with buying a Planetarium ticket. But we will be continuing our deep dive content. We might be doing a mix of both, so we may do a brief star tour at the beginning of a stream, followed by a 30-minute presentation about certain topics. And we have a bunch of topics that you all have suggested that we're looking forward to diving into. And I don't have an announcement about next week's topic yet, but stay tuned for that. And if you have any requests or ideas for topics, put them in the comments and let us know, because we love hearing your ideas, and that makes my job easier too. So again, just shoot a message into the comment section of the video here, or to the Planetarium if you'd like. And we will hopefully be able to dive into some of those topics. If you are watching on the Union Station or Science City Facebook page, I'd encourage you to head on over to the Arvin Gottlieb Planetarium page and give us a like and subscribe to keep up with and not miss any of our future live streams and other spacey updates. So that is the deal. Now, during our live streams, you are always welcome to comment and ask questions live, and we'll be answering those questions live, of course. And we'll look back on the comment section if you're watching a recording of this. Post your question there, and we will try to keep track of that, and hopefully I'll get to them the following week. So yeah, please comment and ask questions. That's one of my favorite parts of doing these. And on that note, we did have a question from our last live stream that I wanted to start things off with. We had a question from Maddie Lou, who asked, it's mentioned that the moon has not had tectonics for billions of years. Is that a process that happens to other planets and other moons? That's a great question, Maddie. And to answer that, we need to talk a little bit about how the moon formed. So you're going to switch on over to our other screen here, and this is a great animation that's going to show us a little bit about how the moon formed. Now, the moon formed a long time ago, billions of years ago, in fact. We think that the moon formed in the early days of our solar system. This is the Earth as it was forming, as debris left over from the formation of our sun was flying around and being influenced by gravity. Now, there's an object that scientists have nicknamed Theia that we think was floating around during this primordial solar system. And this object was about the size of Mars, and we think that it collided with the Earth. When it did that, a lot of its mass combined with the Earth, but then a lot of other mass was ejected out into space. Now, thanks to gravity, this mass did not fly away from the Earth, but it continued to be close to the Earth, orbiting around, and then continuing to be influenced by gravity. The two masses eventually coalesced again, with the Earth reforming, and this object ending up as the moon. Now, there's evidence to support this theory, as a lot of the material brought back from Apollo scientists is very closely related to materials and minerals that we have here on Earth. Now, After the moon formed, it was very hot, just like the Earth was very hot, covered in molten lakes of lava. These lava lakes have cooled and formed the Maria that we see on the moon, and we'll take a look at the modern-day moon in a bit. Now, throughout the early days of our solar system, there were a lot of meteors and other objects that were flying around, and these objects collided with the moon, forming a lot of the craters that you see on the moon. Today, however, the moon is, as far as we know, not very tectonically active. It is cold, so it does not have a molten core, at least not remotely like the Earth's molten core. And we have studied the surface of the moon. The Apollo astronauts left seismographs on the surface of the moon, and other missions have studied moonquakes and things like that, which there are some minor ones, but again, we do not consider the moon to be as tectonically active as the Earth today. And so to the last part of your question, Maddie, was, is this a process that happens to other planets and other moons? The reason that the moon has stayed all rocky and cratered is because it doesn't have an atmosphere. Now, we're lucky that the Earth has formed an atmosphere, and we could dive in deep about how that atmosphere formed. There are a lot of theories about that, but just know that because the Earth has an atmosphere and some other planets have atmospheres, those gases prevent objects from seriously impacting or changing the surface structure of larger planets. But moons are a lot smaller, and most moons do not have atmospheres, and those moons that don't have atmospheres often look similar to the moon. In fact, there is a famous planet, the closest planet to the sun, that you could easily mistake for the moon, and that is Mercury. So here is Mercury up close, and really it's almost impossible to distinguish from the moon. Yeah, that's a great question, Maddie. Thanks for asking that about our moon. And I just saw we had a comment come in from Barbara saying hello from Alabama. Thanks so much for tuning in, Barbara. I appreciate you joining us. Barbara wishes that they could see the stars tonight, but there's a tropical storm. I hope that you're safe, and I hope that everybody is safe around the world right now, of course. That's the great thing about these live streams, is that if there is bad weather, then hopefully you'll get a peek at the stars. And of course, if there's ever bad weather, or if it's too hot, the planetarium does have air conditioning. So come on over and get a nice unobstructed view of the night sky at the planetarium. And there are a lot of other applications that you can use. Barbara says that they're using Star Walk, which is a great app, and there are a lot of other apps that are free or you can pay for that will be similar to the piece of software that we will use today, which we're going to stealthily transition to, called Stellarium. This is a piece of computer software you can install on your Mac or PC. It's free and open source, and it's a great tool to learn about space on the computers. And that's what we're going to be using. That's what we've been using for our star tours for a while. And we're going to use that to take a little tour of our early summer skies. So the Planetarium will be relaunching with our live star tour. That is our most popular show. That's going to be twice a day, every day that we're open. So be sure to check that out. And our schedule, again, can be found in unionstation.org. So this stream will just act as a little preview for what you can expect when you come to see one of our live star tours. And of course, it's impossible to compare to the real Planetarium experience. So be sure to come check that out. Plus, I'll leave some things out so you have to come see it. Now, this is our Kansas City skyline standing in front of the Liberty Memorial. Of course, in the daytime star, our sun, is drowning out all of the surrounding starlight. So we want to fast forward time with Stellarium. We have control over time and space, so we are going to hit the fast forward button a couple times, which is going to get the sun to start setting. And here we go. As the sun sets, the stars come out. Now, the sun is setting pretty late at night, so our star tour will be spent pretty late as well. I recommend waiting an hour after sunset, where the sun's light and twilight will be far away. So we're actually going to go over to about 12:30. You can even still see a little bit of glow from the sun, but that should be good. And I'm just trying to keep an eye on the comments as we're going along. Jennifer is chiming in, saying that she loves the background. I do too. It's great that there are all sorts of different colors found in space, just like there are all sorts of different people found on the Earth. And Jennifer is asking, if the space station is 254 miles high, why did it take the astronauts 19 hours to reach it? Ooh, that's a great question, Jennifer. I dived into that a tiny bit when I talked about the SpaceX launch, and if you guys missed that, we launched American astronauts aboard an American spaceship for the first time in 9 years, just a week or so ago. And after they launched into space, they were orbiting for 19 hours before they caught up with the space station. And that's because the space station is traveling really, really fast. And to catch up to that moving target, they have to be very careful and not overshoot. So it involves a lot of very small maneuvers that when they get to space, their orbit might be a little bit different than the space station, so they have to change a little bit to kind of slowly catch up. And eventually, over a process that takes 19 hours, they sync up and they're able to dock with the space station. That's a great question, Jennifer. Thanks so much for asking. And I see we got a couple other questions. I'm going to keep an eye on these and return to them throughout. We're going to hopefully we'll intersperse them throughout here. I'm just going to check them to make sure there might be a good time to bring them up. All right. Okay, so let's go ahead and move on. And we're going to start over here in our northern sky. There are a pair of patterns here that I like to start out with. And that is the Little Dipper and the Big Dipper, these two big spoon shapes in the sky. In the summertime, you'll find the Little Dipper below the Big Dipper. And in the winter, you'll find them the other way around. Now, these are two asterisms, not official constellations. They're sort of unofficial star patterns, but they are very well known, and they do belong to two official constellations called Ursa Major and Ursa Minor. And we can see these constellation patterns here, the Big and Little Bear. Now, I did see that we had Alex chiming in saying that it looks cloudy tonight in Kansas City. Yep, sure does. But Alex is reading that there's a comet within the Big Dipper over the next few days. Now, comets are amazing. I talked about comets in depth during a few of our previous live streams. Don't forget, you can always rewatch these live streams if you want. Just go to Union Station's page and you can find all these live streams posted. And we might work on doing a massive post that has a list of all the live streams so you can kind of easily find them, because I know it gets kind of hard over time to find those. Let me double check. Yes, so this is a pretty famous comet actually, called Comet Pan-STARRS, which is kind of a cool name that really is an acronym. But it looks like for the next few nights, the next 8 nights apparently, this comet is going to be crawling across the bowl of the Big Dipper. And it's, let's see, it might be kind of faint, but there's a chance that you might be able to catch it. And theoretically, comets are in our Stellarium software here, but this one might not be available. But again, it looks like this comet is just barely not visible. So this has a magnitude of 8.5, and the higher number of magnitude, the dimmer object is, and humans can see about up to magnitude 6, which is the dimmest thing a human eye can see. And so this is a little faint, but with a pair of large binoculars or a decent powered telescope, you might be able to see this comet kind of scooting across the scoop of the Big Dipper. So thanks for bringing that up, Alex. I appreciate you bringing that up. So we're going to return back to our view of the night sky here. We did get a question from Jennifer Flory asking if we are open on weekends. We are open Wednesday through Sunday right now. That's our current schedule. These things may shift around, so just be sure to tune into Union Station's Facebook page or unionstation.org for updates on the schedule. We are generally always open on weekends, though. It's just some of the weekdays we're occasionally closed. Connie, hello from Lenexa. That's where I'm from. I grew up in Lenexa. I'm a Kansas boy. All right, so getting a little sidetracked. We're going to run back over here to our star tour. We're going to point out a constellation that's setting in our summer skies. You won't be able to see this for much longer. It is Leo the Lion. You can find Leo by looking for this asterism that looks kind of like a backwards question mark or a coat hanger hook. This is the lion's head and his mane. Here's the lion's body, his front paws, and his tail. Kind of looks like he's lying down to me. You know what I mean? Get it? Lying down? Alright, yep, that was terrible. So Leo represents the Nemean lion. This was the ferocious beast that Hercules fought and defeated during the first of his 12 laborers. It is one of these zodiac constellations, and if you want to learn all about the zodiac and how it works, I talked about that a little bit in depth during last Wednesday's deep dive, which was all about the science of Harry Potter. So if you are interested in Harry Potter, be sure to rewatch that stream if you missed it. But I talked about the zodiac in depth there, and I talk about the zodiac a lot more in depth during all of our live star tours. So we are not going to dive in depth into it in our stream today, but I just wanted to give a little plug about that. There are 12 zodiac constellations officially, although there is a 13th that you might learn about if you come to the planetarium. Now, if we continue on here, there is a constellation that we can kind of see behind the Liberty Memorial here. It's called Virgo the Maiden, another zodiac, and she has a very bright star named Spica in her constellation. Spica means ear of grain in Latin, which actually relates to this constellation. So Virgo is kind of like a big stick figure. This is Virgo's head. Here are her arms, her body, and her legs are kind of behind the memorial here. Nope. All right, there we go. Listen, it's been a long year. Wait a minute, it's only June. All right, Virgo, Virgo the Maiden. Virgo represents a goddess of fertility or harvest. The Greeks called her Demeter, the Romans called her Ceres. In many artistic depictions, she's often shown as holding an ear of grain, representing fertility, and Spica means ear of grain, as I said, and you can see the constellation is holding Spica. Clay is mentioning, or is asking, if there is a story behind the new astrological symbol that shifted some people around, announced by NASA. So there was a news story going around. Well, this news story kind of crops up every once in a while, how the dates of the zodiac constellations shift around. And there are two reasons why they might shift. One is because constellations are not the exact same size. The zodiac dates, your zodiac sign, those dates are divided very evenly between 12 sections of the year. But constellations are different sizes, and the sun passes in front of different constellations, which is how they signify your zodiac sign. But it spends different amounts of time in front of each constellation. So your zodiac sign may not actually be your real zodiac sign, or the sun may not be in front of or in the house of your sign, depending on those dates. But the thing he's mentioning, Clay is mentioning about this news story, is that the dates slightly shift because of something called precession. The Earth is basically sort of wobbling in its orbit. So if I spin a top, you can see that it spins around really quick, but it also does this sort of slow wobble, and the Earth is doing that same wobble. I know it's not really working amazingly on my phone case, but hopefully you can kind of, you can picture a top wobbling, right? And the Earth does the same thing. This happens very slowly, though, over the course of about 25,000 years, but it happens quickly enough that over measurable periods of time, in human life at least, the stars will slightly shift in their positions. And so these dates are occasionally updated when these shifts become significant. So that's kind of the story behind that, that thing that Clay is mentioning there. Tom is asking, can we see the space station? And you for sure can. I just saw it the other night. Actually, it was very bright. If I Google, can I see the space station, the top result is spotthestation.nasa.gov, which is an entire website dedicated to spotting the International Space Station. The space station makes one orbit around the Earth once every 90 minutes, which is very frequent, but it will be moving across different parts of the world at different times, and the reflectivity, how shiny it is based on the angle the sun is hitting it, will change as well. So there are certain times and certain days where it is brighter than others, but spotthestation.nasa.gov is a website that will help you track and find those really good viewing opportunities, so you can for sure see the space station. All right, we're going to move back on over to our stellarium here. And there's a very bright star. In fact, it's the brightest star you'll see in the early night sky tonight. That is Arcturus right up here. It's part of Boötis, a hunter constellation that, to me, kind of looks like an ice cream cone. Boy, I could use some ice cream right now. Boötis was a hunter that was said to be protecting his flock from bears, and some people could say the Ursa bears were the things he was protecting his flock against. Arcturus means watcher of the bear in ancient Greek. There's actually a nifty trick you can use to find Arcturus and Spica using the dippers here, and it's kind of hard. Let me try to angle it. There we go. Just use the handle of the Big Dipper and make an arc through this handle across the sky, and this curve kind of passes through these two stars. And then if you just remember this little saying, arc to Arcturus and speed on to Spica, you can easily find and remember these two stars. Again, arc to Arcturus and speed on to Spica. All right, so where are we? We are in the south, but we're going to continue on over here. And thank you so much for chiming in and commenting, guys. I'm really enjoying the interactivity today. Tammy is asking, is there anything that we know about Earth-like planets that NASA's found? NASA has found thousands of Earth-like planets, actually. And when we say Earth-like, we mean planets that are a similar distance to their star based on how bright that star is. So obviously we can't see these planets up close. They're still too far away. But they are sort of in this Goldilocks zone that could mean that there are conditions there similar to the conditions on Earth. So none of these planets have been seen up close. In fact, there are places in our very solar system that are more likely candidates for places that have life. So we'll probably explore those before we explore those other planets. We call them exoplanets, planets outside of our solar system. And then Clay is asking if meteors or asteroids have caves. That's an interesting question. So a meteorite impact will sometimes create a cave. But these asteroids may have caves, although a lot of asteroids are sort of more like loose collections of gravelly rock that are sort of shifting around and changing shape. Let me see if I can find a really good picture of an asteroid that... yeah, perfect. Here we go. This is one particular asteroid that's I believe it was the spacecraft Hayabusa explored. This is, I think, a shadow of the spacecraft that touched down briefly and collected a sample. But you can see this asteroid close up just looks like a big ball of gravel, essentially. But there are some asteroids that are larger that have more complex structures, so I suppose that they could probably have caves. Connie has a message for us. Growing up in Kansas all my life as a child, I remember seeing so many stars in the summer night sky. The sky was filled with bright stars, twinkled so bright, but now it seems like the stars are few in numbers, aren't as bright, and don't twinkle very much. Connie, that is an experience I think a lot of people share, remembering the stars, especially far away from city lights, and especially before city lights became so bright. Fortunately, the stars are all still there, and there are places you can find that are just as bright, or at least close to bright. In fact, you can find websites that will help you find dark sky spots. This one is darksightfinder.com. And this basically just shows you light pollution around the country. I believe this goes for the world too, yeah. And so there are places you can find, even in eastern Kansas, that have a decent lack of light pollution. So you can still see the night sky pretty clearly. And summer is a great time to view the stars because the Milky Way galaxy is popping up. In fact, I'm going to talk about the Milky Way next. And to do that, I'm going to hide our Liberty Memorial. We're going to move to a more rural spot. This might remind you a little bit more of where you grew up, Connie. In our summer skies, we are able to see, if you get away from the light pollution of the towns, you can see the outline of the Milky Way galaxy. This is the galactic core where the Milky Way is brightest and where it shines brightest, and you can still see it if you find a good stargazing spot. Near the core, there is a constellation called Scorpio, which is just now rising. This is a summer constellation. You can find Scorpio by looking for this fan of 4 stars. Here's the scorpion's claws, and its body curves downwards there. This star at its heart is called Antares. This is one of the reddest stars in the night sky. It's so red, in fact, that ancient people often mistook it for Mars. That's actually how Antares got its name. The word Antares means not Mars. So ancient people named it that so they didn't accidentally call it Mars. Scorpius is the monster that the hero Orion battled. Orion is a constellation you might recognize. It's a winter constellation. Now, I'm going to cheat a little bit and fast forward just slightly because there's a constellation rising a little bit later I want to point out, and that is Sagittarius, the Centaur. You can find Sagittarius by looking for this teapot asterism. Here is the spout, the lid, and the handle. And the rest of the constellation is meant to be an archer. And this archer is pointing right at the galactic center. So this is the core of our galaxy. If you come to the planetarium and check out one of our star tours live, we actually dive and fly to the core of our galaxy and find out what's lurking at the center of our galaxy. So you definitely don't want to miss out on that. And let's move over here and look towards the east, because there are 3 bright stars that have just now risen in our evening sky. These 3 stars form a nice big triangle, which appear in our summer skies for the entire evening. And this is the Summer Triangle. This is a famous asterism that ancient people used to help them figure out the changing seasons. The way this works is that in the springtime, you'll see these 3 stars rising one after another, but once all 3 are up, that tells you that summer has arrived. These 3 stars are called Vega, Deneb, and Altair. Vega is part of a constellation called Lyra the Harp. It's a tiny little diamond that represents a harp that belonged to Orpheus, a famous poet and prophet. There it is. Vega is another very bright star. I think it's the 5th brightest star in the night sky. Deneb means tail, and it is the tail of Cygnus the swan. This swan looks like it's flying through the Milky Way. Here's the swan's neck, its outstretched wings, and its tail. This swan was one of the many disguises that Zeus, the king of the gods, used to take when he came down to Earth to, let's just say, socialize with humanity. And then Altair is the eye of an eagle constellation. This eagle was a pet that belonged to Zeus. It carried its lightning bolts for him. So these 3 constellations are very famous, and this summer triangle stands out as signifying the arrival of the season. There's a deep space object in the constellation of Lyra the Harp called the Ring Nebula. It's one of my favorite favorite deep space objects, rather. And this is a remnant of a dead star. We dive in depth all about the Ring Nebula and how stars are formed during our star tours. We also talked about star formation and the life cycles of stars during a previous Wednesday deep dive, so you can check out that stream if you want to learn more, or just come see one of our live planetarium shows. But we're not going to spend too much time diving into that today. And the last thing I wanted to mention is that rising just after midnight are 2 very bright points of light that stand out amongst all the other starlight. They're much brighter than anything around them, and as you can see if you look closely, these 2 points of light are not twinkling, unlike stars nearby. These 2 points of light are are planets. We can actually see the moon just behind them as well, rising later tonight. These are the planets Jupiter and Saturn. All right, let's turn that off. Jupiter and Saturn are 2 planets that are very close together. This is actually unusual. These planets only appear this close once every 20 years. In fact, later this year, in December, these 2 planets will approach conjunction. That is where they appear, the closest that they ever appear in the night sky together, able to be seen in the same frame of a binocular or telescope. So that'll be quite a sight. And stay tuned, we will likely have a viewing opportunity with telescopes when that rolls around. That'll be on December 21st, so mark your calendar. Before you ask, that is coincidence. That lines up with the winter solstice. The previous great conjunctions of Jupiter and Saturn did not line up at that time. That's just a total coincidence. And we're not going to dive into these planets in depth because later this summer we will be flying to these planets and exploring them. We are going to be flying through the rings of Saturn. We are going to be learning all about the mini moons of Jupiter and Saturn during our live star tour. So you're not going to want to miss that. We will fly to these planets in 3D, so be sure to reserve your tickets to our star tour now, and you won't miss that. That brings us close to the conclusion of our stream for today. So if you have any last-second questions, pop those in now so I can see them. And we do have one question I'm going to address. Clay is chiming in again, asking if stars make noise, and that's a really good question. A question that is interesting to answer because stars probably do make noise in the sense that they vibrate molecules, which is really all that sound is. However, in space, sound cannot travel because in space, space is a vacuum. And sound travels through wave propagation. So sound is just the propagation of waves in particles and molecules. And so molecules bumping into each other, pushing each other along like a big conga line. That is essentially what sound is. And in space, there is no sound because there is no particles. The space is a vacuum, a lack of particles. So I guess the real answer is that stars would not necessarily make noise. However, you can observe stars and you can interpret their data as sound. In fact, some scientists do this to try to learn or try to decipher different information from them. But in a different way, we are looking for different types of sounds from distant stars in the form of radio waves. Humans have been sending radio waves out into space for a long time, over 100 years. And those are some of the things that we look for when we try to see if there is life out there in space. There are a lot of projects around the world, a lot of big satellites on Earth and in space that are listening, in a sense, to different places for radio waves coming from distant civilizations. Now, of course, radio waves travel at the speed of light, and some stars are very far away, hundreds or even thousands of light years away. So if we ever got a signal, it would be very old, and it'd be hard to communicate directly with any other civilization. So in a sense, stars may be making sound, and our star and our solar system is making a lot of noise. You could say, as humans continue to sort of shout with our digital voices out into space. Hopefully, someday we'll hear a voice that is nice. Connie is chiming in. Thanks. Connie says that they enjoy Sky Station Live. Very informative. Thank you so much. And thank you to everyone who has commented, everyone who's just watched. I appreciate all of you so much. I've had a ton of fun doing these over the past nearly 3 months. It's crazy to think, but I'm very excited to see you all safely at the planetarium again. Go to unionstation.org to find information about how we are planning to safely reopen, again, to members this Wednesday and to the general public next Wednesday. And thank you for continuing to watch. We're going to continue these streams on Mondays and until we say otherwise. Clay, thank you so much. I'm glad you enjoy our streaming sessions as well. See your comments. And since we are reopening soon, and again, we're going to continue the streams, but I just wanted to give a huge thank you to everyone who has helped out to make these streams possible. To Ben, who is my guy in the chair, monitoring the comments and making these streams possible and making them work on all of our Facebook pages. Thank you so much. Thank you to the director of the Planetarium, Jeff, for believing in me and believing in the Planetarium's mission, and for supporting its mission while we've been closed and as we plan to reopen. And thank you to the entire Science City education staff, my coworkers. There is not a staff like it in the world. They are all amazing. And I hope you all say hi to them and come visit us at Science City and the Planetarium when we reopen, because all this we're doing for you all, our audience, and we can't wait to see you again. For now, though, this will conclude our stream for the day. Once again, I've been Patrick Hess, the Planetarium Specialist at Union Station. I will see you all under the stars soon. Goodbye.